Good afternoon. I'm Terry Goldberg. I'm the Executive Director of the Northeast Waste Management Officials Association, or NUMOA, and I want to welcome you to today's webinar. I'm going to hold a minute because a lot of people are still logging on, and I just want to give them a chance to log on before we get started. So for those of you who logged on time, thank you very much, and we'll be getting underway in a minute or so. Okay, let's get started. Again, my name is Terry Goldberg, and welcome to today's NUMOA webinar. We're going to be talking all things plastic this afternoon. It's great to have all of you join us. Before we get started with the presentation, I just wanted to let everyone know we are recording this presentation. We will be posting the recording on the numoa.org website, and if we have a few minutes at the end, I can show you the website. It's a new website. So yes, these slides and the recording will be available via numoa.org sometime after the webinar is concluded. We are really fortunate today to be joined by a colleague from the Association of Plastic Recyclers. We really greatly appreciate their willingness to do this presentation today. The idea for this webinar came out of NUMOA's Solid Waste and Sustainable Materials Management Steering Committee. It's a group of managers of state solid waste and recycling and sustainable materials management programs in the region. The state government agencies managers, and they convene regularly and have recently decided that they would like to do a series of sort of materials management 101 classes or webinars, principally virtual sessions. And so this is the second in the series that we're starting this year. The first session focused on sort of how we categorize waste, solid waste, all the different ways we label waste and categorize waste. That webinar presentation is available on NUMOA's website, both the recording and the slides. So this is the second that we're doing, and we certainly appreciate folks to give us feedback on how this went. We're particularly interested in this webinar in reaching new state employees working in sustainable materials management. And, you know, we recognize that plastics is a interesting but complex topic, and it is very confusing for a lot of people, all the different types of plastic, which ones are recyclable, what do the numbers mean, all the different sort of basic questions people ask about plastics, and that's what our presenter is here to talk about this afternoon. We really encourage all of the participants in today's webinar to post questions. You can look on your GoToWebinar control panel. There's some gray rows, one of which says questions. If you look across from on that row on the right side, you'll see a square with a slash through it. If you click on that, it will expand that feature, and then you can post your questions. If you have questions, if you have comments, we'll have hopefully about a half an hour at the end of the presentation for questions and discussion. So we really encourage you to use the question box in order to let us know what you're thinking and what your ideas and questions are. There is a chat feature, although it's not shared it's not a chat like Zoom where everybody can see the chat. The chat is mostly, we use it to communicate with me, the convener of this webinar, in order to, you know, if you're having some kind of problem, can't hear, or whatever, and if I can help, I will. I'll be monitoring the questions in the chat and facilitating the questions at the end. So let's get underway. We are really pleased to have with us Curt Cozart. He is the Chief Operations Officer for the Association of Plastics Recyclers, the only North American association dedicated exclusively to plastics recycling. And he's president of Common Sense Solutions, a consulting company specializing in plastics recycling, plant design, and improvement. He led the 2014 development of the new APR design guide for plastics recyclability, the premier American authority on the recyclability of plastics, now adopted into law in California, and continues to supervise the improvement of that document. He can provide technical due diligence for many of the major North American plastics recycling mergers and acquisition deals. He has worked in the plastics recycling industry since 1991. It's a long time, where as a project manager for a mobile chemical company, he built the first North American film recycling plant dedicated to LLDPE stretch film. He served domestically and overseas in the U.S. Army as an engineer officer, attaining the rank of captain. He holds a Bachelor's of Science in Applied Engineering Mechanics from the United States Military Academy at West Point. So it's really a pleasure to have you with us, Curt. I'm going to turn it over to you now. Thank you so much.
Okay. Thanks, Terry, and thanks everybody for joining us today. So what we're going to do is we're going to kind of explain plastics, and what I'm going to do for right now is I'm going to turn off my monitor. Terry and I thought that would be a good thing to do while we're doing the presentation. I've got a couple of demonstrations that I'll turn the monitor on for when we do that. So turn that off. Oh, I thought I was going to turn it off.
Now you turned the webcam off. You turned off your the slides.
Oh, okay. All right.
So the webcam is the little. There we go. Okay.
There we go. All right. Thanks, Terry. All right. I know a lot about plastics, not about GoToWebinar. How about that? Okay. So with that, so as Terry said, type in your questions. I'm sure there'll be a lot of them. And then we'll try to get to them at the end here. So who is APR? It's the Association of Plastics Recyclers. Really the tagline is the voice of plastics recycling, international, and that it's North America and actually South America and kind of China and India right now, is moving in that direction. But really, it's the only plastics or the only organization that is exclusively in plastics recycling. We have recycling organizations that have plastics arms. We have plastics organizations that have recycling arms, but nobody does exactly what we do. Our mission really, is depicted in these puzzle pieces right here. So take the recycling infrastructure and the package design and put them together so that they work together, and that we define those puzzle pieces so that they work together, and so then that items that are actually placed in the packaging stream, in the recycling stream, actually do get recycled, and that they don't affect the quality or the yield of the recycling infrastructure. How do we do that? We have this document called the APR Design Guide for Plastics Recyclability. We just refer to it as the design guide. It's kind of the, it is the document that plastics designers or package designers go to say, hey, I need to choose this label, and I need to choose this package or this closure and this color and this, all the different things. So we produce this document. It is open source, it's online, so we try to reach as many of the package designers as we can. A lot of the times we don't know, something new comes out, and we don't know about this item. So we create a test method or test methods that replicate the recycling infrastructure, what's happening out there. So they can take something that they don't know about, they can put it in this, go to a laboratory who is conducting our test methods, and then they can say, hey, this was actually going to work, or this isn't. We do training programs, really, really in-depth training programs with these folks, so they do that. And then we also are doing a lot of communication, and our big push right now is in advocacy. So we're reaching out to the state organizations, or to the states, to the people that are making policy, such as yourselves, and we are making sure that things are done, that laws that are passed are good, well thought out laws and policy. So how does the plastics recycling chain work? You see over here on the left, okay, you have a package manufacturer. So they're taking and creating a package. Then they take that package and then they sell it to a brand. The brand uses it and sends it to the retailer. So nothing surprising here. The consumer then uses it, and then hopefully the consumer puts it into the curbside or some kind of a bin where it is then collected. When it's collected, a lot of you all are involved in this part of it. It goes to a hauler or to a MRF, okay, where it is sorted, and then that MRF then takes it and and sells it to a recycler. That recycler we also call a reclaimer, and so they make it back into a high quality recyclable product, in generally in pellets, that the manufacturer can use again. So that's how it works. And we have members that represent every piece of this value chain. APR has, let's see if I can make this thing move forward. There we go. We have 260 members and people that, so every part of that value chain, waste management being a MRF and a hauler, Eastman making material, Reiki is a component manufacturer, a recycler would be our planet Earth. So everybody in that value chain, 260 of them are members of the APR. And by the way, we are an organization that is growing, whereas many organizations with the downturn in the economy are seeing membership falter. Ours are actually, our dues are growing, our membership is growing significantly. Now let's talk about our chasing arrow symbols. So a lot of misinformation about on these. Okay, these are a symbol that is owned currently by ASTM. And what they are is they only identify the material. They don't mean anything about recyclability, okay? And what they do is they put them on the bottom, or either on the, printed in a label or embossed in the package, is everybody's familiar with. And it just says, hey, this is what that item is. It's the equivalent of walking up to a wall and drawing an arrow, drawing a triangle on it and saying drywall. It doesn't mean that that drywall is recyclable. It doesn't mean anything. All it means is that material is drywall. Now, the actual name for this symbol is called the resin identification code. It is not a recyclability code, but the way that it's used is it's a consumer message, so that the consumer can look on it and say, my local community accepts number one. This is a number one. I can put it in that stream. That's how it was intended to be used. There is some law now, state of California, in their latest bill has said that the chasing arrow symbol is it's misinformation, so they want a triangle. But we understand that the consumer, because a long time, it's been since 1989, I guess, since these symbols have been out there. The connotation is that it's a recycling symbol. It's not. What are some of the things, and why are plastics, why do we have different kinds of plastics? So I get people that ask me a lot, so why can't we just have one kind of plastic? And I said, well, plastic is really just a a type of material. I said, okay, well then let's have what I said it'd be the equivalent of saying, let's have one type of metal. So what is that metal we're going to choose? Are we going to choose cast iron? So our airplanes have to be made out of cast iron? Or are we going to our airplanes need to be titanium or aluminum? So we're going to make everything else out of something really expensive that titanium or that aluminum or titanium doesn't work for. So that's what we do. Plastic is very similar. So plastic your resin identification code number 1 is PET. What that's and it is a very recycled plastic if the package is designed appropriately. So why do we use it? Because it's stiff and it's strong and it's heat resistant, okay, and it's clear. So when you make a water bottle, you want to drink out of a clear package. A soda bottle, it's more apparent, or it's more appealing if you choose a clear package. Also, what it is you can put your put soda in this bottle, and because it's got good oxygen and carbon dioxide gas barrier, that your soda won't or beer, if it's a plastic beer bottle, okay, won't go flat on you. Whereas if you use any of the other plastics, it will go flat on you. So that's why we use a lot of PET is used there. It's and by the way, it has a high degree of food and say FDA credentials. So but then it's in the format, and it really depends on the format. Everybody's familiar with the water bottle and the Coke bottle there. But there's also PET film. There is, any kind of polar fleece. If it's polyester is just another name for PET if it's in a fiber form. But then also we have some things that have some additives and things like that Simply Orange bottle up there that we don't necessarily know whether it is or not recyclable. But I will tell you that Simply Orange now has converted completely over there. So that is a change that we've seen. But then we see that clamshell down there. So we have so many different types of clamshells and whatnot that could be recyclable or not, depending on what the location is. But that's why we use PET. It's clear, good food grade, and keeps things from going flat on us. Next one, HDPE. So HDPE is very strong and light, okay? But it is not clear. And so that milk jug that you see down there doesn't have any color in it. That's really the natural HDPE, but because the surface area, it reflects light a little bit differently, so it appears to be white. But it's not really. A good moisture barrier, but a really bad oxygen barrier or carbon dioxide barrier. So if you put your soda in a milk jug, it would go flat. But if you put your milk in a soda bottle, because of the light going through it, it's going to go, it's going to sour on you sooner. So that's why we choose those things, which package is going to give us the desirable, what we call physical properties. Lot of piping, particularly drainage piping, is made out of HDPE. A lot of recycled material, because we use a lot of drainage pipe. The drainage folks want to they're going to buy material, so they buy a lot of colored HDPE bottles, whereas with a milk jug, it's primarily those bottles are going to go back into food grade bottles. For PET, about half of that is made back into bottles, so back into food grade or even non-food grade, like a Windex sprayer, and then about half of that is also made into fiber, like carpet or polar fleece. How about the next one? The next one's number 3, recycling or resin identification code number 3 is PVC. Now, PVC is very stiff and clear and has really, really good chemical resistance, okay? And by the way, it melts, you can melt this in your oven very, very easily. Melts at about, under 200 degrees. And the cost of it is not very, it doesn't cost that much either compared to some of the other ones. PVC, there's really no recycling program for that. A lot of the reason is, one is that it is so egregious to other materials when we mix it in with any of the other plastics, because we have to melt this plastic down in the process. It melts and burns before the other plastic melts, and so then we end up with a burnt plastic. So it would be a dark color, a burnt color. So not a whole lot of, or I don't know of any recycling programs for PVC. Where we see them is like in this blister pack, which is maybe there was some electronics or something in that pack there. But a lot of companies going away from PVC in any of their package, particularly if they have a sustainability goal. Where we see PVC, we see that on vinyl siding, so construction materials, and things like that are recycled, if when they tear a house down, but it's not the packaging that we're talking about. LDPE, so we call this low density polyethylene. So similar to the to our recycling number 2, which was high density polyethylene, they're the same chemical structure, except for a couple little tweaks. Low density polyethylene is really what we see a lot of in film. So you see that overwrap of some bags. You do see it in like real flexible bottles, like you see right there. Those bottles, when you put them in the recycling stream, might accidentally get recycled into the HDPE stream, but they're not officially recyclable. But this material, we can make a film out of it, and it's stretchable, it's strong like that. Whereas with if we chose high density polyethylene to make a film out, it would break on us. You'd be able to poke a hole through it really easily. So that's why we have this low density, so that it is stretchable. How about polypropylene? Number 5. So polypropylene is also recycled. It's the 3rd most recycled plastic, and what it is, it's stiffer than the others. So you see it made, tubs made out of it, lids made out of it. It's also much higher temperature. So that's when if you get a takeout tray that says that you can microwave it, it is polypropylene, so that it can withstand the heat and won't melt, whereas the others will. And that's why we can use it for these other what they call hot filling. You know, when the FDA requires packages to be sterilized a certain way, they call that hot filling a retort. Also, it's very good. So it's really stiff and it has a good moisture barrier, and you can use it on hinge things. So a flip top on a package, you know, you can move that hinge over and over and over again, and it doesn't fail on you. Whereas if you used another one, that would break. So that's why we use polypropylene. How about polystyrene, number 6? So the most common, here are the most common ones that we see. We see what we call expanded polystyrene, or what, you know, it's actually a brand name, but people call styrofoam. That is a foamed polystyrene. And then we see it in solo cups. And so most of the cups that you see that have a color on the outside and that are white on the inside, Solo is a brand, but we see those are made out of what we call high impact polystyrene. Easily foamed. Neither of those is recyclable. And the reason is, well, one is the styrofoam is it's just, you know, to transport it, it's so light that to transport it to a facility takes so, you're transporting a lot of air. You can get about 1/5 of the amount of material in that truck that you could from others. We also see the many of the cups now that are no longer high impact polystyrene. They're moving to polypropylene or PET or something that's more recyclable. A number 7 is just the catch-all. It could be a blend, it can be a biodegradable material, it can be something, it's just a catch-all. There is absolutely no program for anything that is number 7, because we just don't even know what it is. But what does make something recyclable? And many of you guys already, you know, follow the are aware of the FTC green guides and whatnot. APR's version and take on this is, you know, 60% consumer access. So, you know, does the consumer have the opportunity to recycle it? So 60% of the population needs that. Doesn't mean that it's actually recycled at that rate. In fact, no plastic in the United States is recycled at that rate. No post-consumer plastic. It needs to go through the infrastructure. So the infrastructure not only is a sorting perspective. So we have companies that say, oh, our material went through the MRF. And I said, well, no, but it doesn't only have to go through the MRF. It also has to be cleaned and processed by the reclaimer or the recycler. And then it has to be manufactured into an identifiable product. So there has to be a market for that. So think of it as a supply, which is that consumer access, you know, processability over there on the right side, and then over there on the down at the bottom, is there a market for the material? So that's how we define recyclability for plastics. What plastics have consumer access, have met that 60% threshold? So not surprisingly to anybody, so PET, remember that's our resin identification code number 1. You know, those are our water bottles and carbonated soft drink bottles. Our high density polyethylene, our recycling, our resin identification code number 2, milk jugs and laundry detergent bottles. Our recycling, or I keep saying recycling code, resin identification code number 5, which is polypropylene. Those are our tubs and lids. And then our polyethylene film, and that is that LDPE, linear low density primarily, but it can also be other polyethylenes, and that's in the store drop-off. So that does not, we are not an advocate of putting film into MRFs. The MRFs don't generally like that. So that's what meet the 60% access, is those 3 items. Now, luckily, or not, or I shouldn't say luckily, not coincidentally, most of the consumer facing packages are made out of that. So polyethylene, polypropylene, high density polyethylene, and PET. So 81% of the packages that the consumer actually touches and interfaces with are made out of the 3 things that are that already have or met that 60% consumer access standard. So what are the things that could cause poor sorting? So many of you have been to MRFs and whatnot. A lot of these things are things that are affected at a MRF. You know, so metallic things. So a plastic package that has a metal closure on it, that has a metallized label like the ones that we see here, or whatnot. What happens is that after the MRF has put this into a bale of, in this case, PET, then we have to pass a metal detector. And that metal detector can see this stuff, and sometimes these things make the metal detector believe that it's a big chunk of metal. So we see things, you know, so metallic items like that, and it completely make the package not recyclable, because you know, it gets kicked out and basically gets thrown away. Small items like this lip gloss here, or lip balm. You know, the MRF sorts glass by breaking everything and putting it through a screen. So things that are super small like this, they are going into the glass stream. So things that are small are not recyclable for us. Things that are flat, you know, the way that a MRF sorts paper and from containers is, you know, 2-dimensional or 3-dimensional, and so we can have very flat plastic that looks like a piece of paper, and so it can go to the paper stream rather than going to the plastic stream. Dark things, you know, a MRF and a plastics recycler uses light, actually near infrared light, to identify the plastic. So it goes in there, it shines into the plastic, and then they have a camera that looks at it and sees what they see back. Black colorant absorbs that light, and so the camera doesn't even see anything. It doesn't know that that package even existed. And anything with PVC, as I said, PVC is so egregious. So where would we see PVC on a package? Maybe it would be an overwrap. Think of it. Think of a tamper evident sleeve that you put on the top of a medicine bottle to make sure that you know, nobody has tampered with that material. So we want that sleeve to be completely removed. Otherwise, if we have a little bit of ring on it, we're going to know that it's there, and that bottle completely gets kicked out. So it's those kind of things that we are talking to the package designer about, so they can choose the right things. So items that don't cause trouble. Okay, I'm going to turn my video on here. Okay, so caps and closures. So there's there is a lot of discussion out there of caps. You know, take the caps off. Don't. Hey, we see people that claim to be super technical that write these reports that say there are different kinds of plastics and they can't be separated because they can't be recycled because they're different kinds of plastics. Well, it's on caps and closures. It's as simple as this. Okay, so I have this is a bottle of water. Okay, and here I have green little bitty flakes. Okay, so what we do in a recycling process, we grind everything up into these little bitty flakes like this. Okay, so we're going to grind the whole bottle, the cap and the closure and everything. I mean the bottle and the closure. Here, these little flakes are polypropylene, which is what a closure is made of. So if we ground them all up, okay, so I'm going to take them, mix them together like this. This is what we do in the recycling process. I'm going to put them all in this tank of water. We call it a float sink tank in the recycling process. Okay, where does our PET? Here's all of our bottles. They're all down here. All of our caps are up here. They float. So we just skim off the top and skim off the bottom. And so we want caps to stay on the bottle because we're going to take that material and we're going to sell it. And we're going to sell the material that sinks because that's PET. That's what we want. So really, we have a whole program called Caps On. We want those, and we want them on pretty tight because we don't want them falling off at the MRF. If they fall off at the MRF, they're going to go in the glass stream. So we want those on there. And those people that are telling you that they're different plastics and you can't recycle them, it's just not true. Many of the labels, so the companies design those labels, they put them on the bottles. Hopefully they choose the right label and the right adhesive of the label. Those things don't cause problems to us. And we can take bottles like we see the PET bottle over here on the left. This has got a polypropylene closure. It's also got probably a polypropylene, we call a wraparound label, and we can take those off, dissolve the glue, and we can make that back into a water bottle or back into a Coke bottle. Laundry detergent bottle here, we can go back into laundry detergent bottles, we can go back into pipe. Now, if it was a milk jug, which is the same plastic, we can go back into food grade. What's the current situation? What is really happening? You know, the narrative here, you see plastics recycling doesn't work, it'll never will. This report right here says because they're the different plastics, right? The reality is we have capacity. We are making that material, like I said, go back, be truly circular, go back into what it was made of. The plastics that we want, you know, the PET, the HDPE, and the polypropylene, and the polyethylene film, and we have capacity for that. We just don't have enough feedstock. We can't get it from, and it's really consumer participation. Some of it is consumer, is a conscious decision by the consumer. Some of it is the consumer doesn't have the means to have it picked up and put into the stream. But we need more material. In general, we have demand, but we just don't. We're using everything we possibly can get and don't have enough material. What's happening? We're seeing brands are changing their portfolios. We talked about those beer cups. The beer cups that used to be polystyrene. Brands know that those polystyrene, that polystyrene is not recyclable. We're seeing them change. We're seeing your big fast food chains. If you remember what their drink cups used to look like, was a wax coated paperboard with a polystyrene lid and a polypropylene straw. Very, very not recyclable. Now you see them going in there. They have a clear polypropylene cup, and by the way, that lid is also polypropylene, and the straw is polypropylene in most cases. So, and it doesn't have a label. It has a direct print on it that, by the way, washes off. So they're moving towards things that are recyclable. Now, why is that? Pretty much everybody's got some kind of commitment. We're seeing here, this is the global commitment signatories that's from the Ellen MacArthur Foundation and the New Plastics Economy. The general commitment to that is 100% designed for recyclability, and maybe 25% of reuse, or reuse would be the wrong term, of what we call post-consumer recycled material content, reusing that material back into your stream. So these brands have made their commitments. It's 2025 is when these are all due, at the end of 2025. And so brands are changing their packaging like crazy. Now, we see this happening. APR has remember, we create test methods. And when we, some test methods, when you do the test, you can also apply to APR to be recognized that you passed that test. And the test is not cheap. The labs charge quite a bit of money. APR, and then APR charges something to review and write the letter. 2 years ago or 3 years ago, we had 19 of those applications for the whole year. Last year we had 50, so almost 3 times as many in three years. So we are seeing packaging, or plastic packaging, changing. Might not always be public about it, okay? But the brands, many of certainly all the big brands, many of the medium size, and kind of the smaller ones are falling in line. So we are seeing that that happen. Other thing that indicates that, we do an all-day training session with brands, and we've had so we charge them for the all-day session. But what they do is they take all of their packaging, and generally their engineering, sometimes their purchasing folks, for and many of these are global. So we take everybody that's employed by them in those fields, and we do an 8-hour training session with them. And so you can see right now, those little twos there show you how many times that these companies have done it in a row. Kraft Heinz owns the record for 3 years in a row. 3M owns the record for the number of people. So they took their first session, had about 100. Second session, they required of it of the whole engineering group. So we had 736 people that spent 8 hours with us training. So they are taking it seriously. So you think about what that investment was: 736 people for 8 hours. What's happening in the future? What kind of trends do we see going on? And like I said, we're seeing companies change their packaging. Legislation, which most of you folks are probably not surprised about. But here from Ameripen, you see the states in red already have extended producer responsibility laws. The states in blue, it's in legislate, are active in this, coming in this year. So right now we have about see my control panel's in the way. 15% of the U.S. Oh, let's see. I just did something. Terry, can you guys see my slide, my screen, or did I go to? I think I got.
No, we can still see your screen. We're seeing the screen on packaging producer responsibility 2022 activity.
Okay.
Yeah, we can see that.
Okay, you guys can see it. Let me see if I can. I think I went to a different desktop is what I did. There we go. Okay, there we go. Thank you. So 15% of the U.S. population already has the or will be under extended producer responsibility. If all the states in blue passed, which our chief policy officer thinks that maybe 3 will occur or will pass it this year, then if all of them pass, we'd have over half of the population of the United States with extended producer responsibility. So we are seeing that happen. It's a trend. I think the packaging companies are aware of this, and they are designing their packaging accordingly when they can. Now, if you had something like a potato chip bag, which we don't want our potato chips to go stale and that need to sit on a shelf life for a long time, well, that's a material that's polypropylene, but flexible. There's no strain for that, or there's no way to collect it or process it. So, there's companies that are working on that, but on overall, we're seeing companies, if they can, they're going to move into our material, into the recyclable and design for recycled materials. Now, chemical recycling. So everybody hears this big, they can call it advanced recycling, call it, there's a number of different names for it, but basically it's non-mechanical recycling. And mechanical recycling, you're going to take a material, you are going to wash it, you're going to take the label off, you're going to put it in that float sink tank to pull materials out, and then you're going to, but it always stays in the form of a plastic. Now, chemical recycling can take that and you're breaking that package back down different degrees, but into other chemicals that made the plastic. And then many times you can take that plastic and then, or take those chemicals and just remake the plastic. So are they, they have the ability, or many of the processes have the ability to take that complicated package and make a really pure material. Mechanical recycling, if you have something that's all glued together and when we wash it, it doesn't come apart, it's all going to get mixed and there's not a whole lot we can do. We can't make a very pure material out of it. Chemical recycling with the right materials, it can. The process is generally more expensive than mechanical recycling. So all of these plants are super large scale in order to get economies of scale. For instance, we have plants that are announced that can take 600 million pounds a year. Well, the largest PET plastics recycling plant in the world is a third of that. So 3 times larger than the largest mechanical recycling plant out there in order to get an economy of scale. And then the business model is that they have to get large volumes of material that they can pay a little for. So they're not going to go out there and buy material in general from the MRF who's selling PET for whatever that the mechanical recycler is paying for. They need the polyester, the PET. A couple of large contracts have been made for, let's say, carpet. So polyester carpet fiber that's been pulled off. Well, that's something that they don't have to pay as much for as for PET and for PET bottles. And there's a lot of volume for it out there. So that's really what their business model, how the business model is structured. Pay, get large volumes of inexpensive material. So the challenge is, though, how do we select, what goes to the chemical recycler and what goes to the mechanical recycler? Who gets paid for that? And what's the system? That system right now is in flux. We don't really know what that is. And like I said, it's super, super large volumes. So we think that chemical recycling, it may have a complementary role, but it's not going to completely replace mechanical recycling, because mechanical recycling can already be circular, making bottles out of bottles, whatnot. Now, you see a lot of press releases that, of chemical recycling that says, they start off first about how much plastic is in the ocean and what the recycling rate, that there's only 8% or whatever they claim, 7% of plastic is recycled in the world. Well, two things are, and then they go about how great the chemical recycling, this new chemical recycling process is. Well, first of all, unless that the process is such that it is keeping material out of the ocean, it doesn't affect that the ocean plastics. And then secondly, the reason that more plastic isn't recycled, once again, is the participation. But that 7% number is misleading, because what's included in that number is your polyester, your polar fleece, the interior of your car, your carpet, your countertops, everything like that, that aren't really packaging. So the truth is it's still not a great number, but about 81% of the consumer-facing plastic, sorry, did I say 81? 21% of the consumer-facing plastic, which is made of polyethylene, PET, or polypropylene, is recycled. So we think, chemical recycling it's not the panacea, but it's certainly going to have a role. Everything that's out there right now is a pilot plant. We have some plants that are now moving into full scale, but they're all pilot plants at this time. So that's kind of where we sit on this, and I think maybe just a couple minutes early, Terry, but I don't know if there were some questions that we wanted to take.
Thank you so much, Curt. You covered a lot of ground. That's great. We do have some questions. I actually had some questions first. So does APR not focus on plastics and things that are not packaged? Is your focus principally packaging, not other products?
Yes, we're focused principally on, so our scope of our design guide is what is put in the curb, what's in a deposit state, or what goes into the store drop-off. Now, a lot of the principles are the same, but we can't say that the plastic that our headlights are made of is not recyclable, because there is a car dismantling service that recycles those, but a completely different process. So those are kind of the closed loop systems, and APR really doesn't focus on the those post industrial, post commercial closed loop systems. We're more packaging.
Okay. I just wanted to clarify that. So I'm glad you talked about chemical recycling. I just wanted to also see if you could comment a little on additives to plastics.
Yep.
They can be inks, they could be plasticizers, bisphenol A, whichever, or various bisphenol compounds, phthalates,
Yep.
and most recently, people are finding out about PFAS use in plastic, particularly packaging. So I just thought if you could comment on that a little bit, and then we'll get into other people's questions.
Absolutely, and I'm glad you asked it. So, so plastics do have, like every plastic has additives in it, okay? And we call them workhorse additives. There's things that you put in there that make these things work, and do what you need them to do. Even the colorants are additives to these. It might be a barrier layer to make for instance, so the reason your ketchup doesn't turn brown is because it's got an additive in that plastic to make sure that it's keeping the oxygen from going through. Now, every one of those, APR's design guide, we try to classify the ones that are common and that are what we call preferred. So they actually, have either been proven or that they don't affect anybody, or we have a lot of tests. So we have ones that have passed testing. Now, and there is a lot of, and anytime a recycled material is going to go into a food process, into a food product, okay, that process has to be FDA approved, or what FDA calls letter of non-objection. So what we call it LNO. And what they've done is they've gone out and they've done a challenge test, and they with that material, they say, here's what my process is going to be, which is always going to have three components to it. It's going to be, I'm going to make sure the material coming in was the plastic was originally food grade. I'm going to have this process that's going to wash the surface and whatnot, and then I'm going to have something that's going to pull out all the harsh chemistry. So those three components. So they have to run according to that, and they do a challenge test that says, hey, look, I proved on my process that I can remove the most harmful, and they put some really, really harmful materials in there to challenge it. And they've shown that and demonstrated that to the FDA. So no package can be made with recycled material into a food grade product or without that. Secondly, then we have items like BPA. So BPA is commonly, there was a scare, what was it, probably 10 years ago, I guess, is when we had the Nalgene bottles and whatnot. That was a very particular kind of plastic. Okay, so that was polycarbonate, and it had BPA in it. But the problem is that there was a lot of misinformation there that, a PET water bottle and a polycarbonate reusable water bottle are completely, totally different molecules. So you're not going to have your BPA in your water bottle. Now, when we get PFAS and other, or not intentionally added substances, the NIASs too. So different, or we're very aware of that. There are some, the vast majority of the plastics don't ever have any PFAS put into them. Okay, there are some fluorinating processes that are very, very uncommon, and we'll make sure, and Many of those are being called out, but it is a concern. I wouldn't say it's a something that is at the highest, has a lot of attention. I don't know that it's I would call it a concern, but a lot of attention from the plastic to recyclers, because we don't want to make any anybody sick any more than anybody else does. And you got to remember, if you are one of these major brands, you're not going to risk your brand on just because you wanted to use some recycled material, if you weren't fully assured that these things weren't in there. So a lot of times the brands are harder than the FDA. And I tell you, there's a particular a large water bottle water company. And benzene is a product that's created from PET. It's a byproduct. Well, we remove that in the process, but the FDA has a limit for it. But that water brand has a limit for it as well, which is 1/8 the value of that the FDA does. So a lot of work going into that, a lot of attention. I'm not sure that I would call it concern, but a lot of attention.
Okay, well, thank you, Curt. I actually was recently reading about a lawsuit against Simply Orange on PFAS. So yeah, I think in that case it's more than concern, but because they were finding it in the orange juice, and it's being promoted as natural. And anyway, it's interesting. A lot of interesting issues with that. So I'm going to turn over to the questions that people have posted. Our friend Mike Nork from New Hampshire asked a lot of good questions or comments. Going back to one of your first slides, I think maybe it was the third or fourth, I don't know, fifth slide maybe. You had the plastic codes. It was all the codes going across. And number 3, you listed it as B, and he just wanted to verify that's PVC, right? The V is related to.
Oh, yeah. So the website that I pulled this off was, it's PVC. And you see the same thing with PET. I think some of them say PETE, but yes, number 3 is PVC.
Okay, thank you. And you had green checks and little red marks or X's. What do those signify in your slide?
So what it was signifying is that just because something is a particular material doesn't mean that it is recyclable. So for instance, we had a X on a polar fleece jacket that's made out of PET. And there's no strain to accept that. It could be, maybe it goes into this chemical process, maybe it goes, wherever, but really what we're showing, and then some of those items have to be tested or we wouldn't know. So that's why the question mark, the checks were to say, yes, they go into the curbside bin, we accept them all the time. The X's were to say that there's no process to, or no current logistical and processing system. And then the question mark is, it kind of depends.
Okay, thanks for that clarification. So the question is, what might be the threshold for something that's considered small? And by that, I think they're talking about things that, when they go to the MRF, they fall out. They don't, they're really not able to be sorted through the MRF because they're too small. Is there some kind of rule of thumb about that?
There is a rule of thumb, and the MRFs call it 2" minus. Okay. Now, what APR
2" minus in length or width or both?
Well, so they put a screen that's 2 inches. Now, APR gets a little more scientific because we're a scientific organization. So we went out and took the average of all the screens that the MRF sorts through. And we created remember, we create lab scale tests. So we took a bunch of material and tried it out in all of these different technologies and and we created a lab scale test. And that test is, well, of course, these items get compressed in the trash truck, right? I mean, because we can start with something that's big and then it can get compressed and we can lose it because it's too small. So our threshold is if it's 2 inches in 2 dimensions. So like a diameter would be, the depth and the width. That it would need to be tested, and then in our testing we have a compression which simulates the trash truck, and then we have basically it's a lottery ticket box that simulates what happens at the MRF, and that screen is actually 1.5 inches by 2 inches. So that's really kind of what that number is. So right around 2 inches in diameter or in 2 dimensions.
So the message for a resident should be, don't put items smaller than 2 inches, sort of in 3 dimensions, in your recycling bin, because they're just, I mean, it doesn't hurt, but it's not going to end up being recycled because it's too small.
It's just a long, expensive route to the landfill.
Okay. All right. Well, that's good to know. I didn't know that rule of thumb. Let's see. Do number 7 items cause issues in mechanical recycling? And does APR get involved with the recycling of biodegradable, compostable material? Or do you consider that to be organics? I was going to ask about biodegradable plastic.
Yeah, good question. So, so we got a couple of questions. So now, number 7. Okay, so number 7 just a catch-all for everything. So I mean, it can just be in general, because we're looking at these things with near-infrared light, and seeing they're going to look like something different. Okay, so they don't really cause a problem in mechanical recycling, except for, once again, they're going to be residue to the MRF, so it's just something that the MRF has to pay to throw away rather than somebody else throwing away. So that's what the number 7s. And then let's talk bioplastics, biodegradable, and compostable. So 3 things, right? So bioplastics, okay, so are exactly the same as a plastic that's sourced from a petroleum source. Okay, it's just how it got there is a little bit different. So for a good example would be the Coke's plant bottle. Coke's plant bottle it's PET and it's indistinguishable from other PET. Okay. So we have that. So it gets recycled all the time, goes back in the recycle stream, is all fine. Now we have biodegradable plastics such as PLA, which would be a number 7. Okay, and a number 7, it could degrade if it was put into a industrial composting facility, of which I think there's 4 or 5 of them in the nation, right? So there's just not very many of them. But once again, they're probably not going to get mixed in with the recycling, with the other plastics, because they're completely a different plastic. Then we have the additives. Okay, so we have additives that are added to a PET or an HDPE or something to make that plastic fall apart and degrade. And there's 2 things. So part of it is the degradable part. So basically what you're making is you're making it fall apart into a microplastic, okay? And then the second part is to make it a bioplastic. Then if it's exposed to certain organisms, those organisms process that into something, and turn it into, basically turn it into dirt. Those things can get, we don't have any way of identifying them. We don't have any way of pulling them out, so they can be added to a water bottle, And what can happen is we put that material, and it never goes away. It's designed to make the plastic fall apart. So when those kind of things are added there, they can make it where it's a reduced shelf life, or it turns many of them turn the plastic kind of a brown. You can think of if something is degrading, it's going to kind of turn kind of ugly color. And a good example of that was a grocery store bag. So in about 2000, around the turn of the century, San Francisco encouraged putting degradable additives into the grocery sacks. And what happened was most of the grocery sacks that were being recycled were going into plastic decking. So now that decking had a 30-year warranty on it in the sun and in the oxygen, and yet they had a plastic additive in there that was made to make it degrade in the sun and the oxygen. So all of those bags weren't recycled. So it gets kind of complicated, but that's kind of it, So we do not encourage the use of a biodegradable or any kind of degradable additive in one of the polymers that is recycled, because it affects the recycling stream.
Thank you.
Sure.
So we've got a question called, can you help with identifying what plastics are in residential asphalt shingles? A little outside the scope of this, but do you know?
Residential asphalt shingles are going to have a, well, one, it's going to be bituminous material. So you're going to have, you might have glass fiber in there, and then you might have some tar underneath there. And you may have, now this is going to get a little bit, what's called atactic polypropylene. So a polypropylene that is actually partially, it's kind of turned into a wax, basically. So you might have that, but I'm not really sure. We don't really focus on, we call it C&D, which is construction and demolition, but most of that is more of a petroleum base than what we would call a true plastic.
Okay, so I encourage more people to post questions. We have one person who sort of it's not really a question, it's sort of a commentary on some of the health effects of particularly microplastics. So, this person is talking about, if you have a plastic cup, say a coffee cup, it can lead to microplastics, assuming it gets into the environment and degrades into microplastics, seeping into your bloodstream through your drink, or this is a direct exposure. Melting plastic into beverage without so much as taste. Studies show that microplastics have strong links to several hormonal health issues, such as a variety of endocrine problems. Yeah. They also have been tied to cancer cases and even fertility issues in women and men alike. Overexposure to plastics, antimony leaching from polyethylene, terephthalate plastic used for bottles. So, sort of for bottled water, drinking water. So, his commentary is about some of the sort of these health effects. I don't know if you're prepared to comment on it.
Yeah, well, I can a little bit. I will tell. There is, if you look hard enough, you can find a study to find something wrong with everything. I can tell you that, and there's a lot of studies that show that. I would say, just question everything. A lot of these things, a lot of the numbers that you see. For instance, the typical number, I can use the example, is, hey, 7% of your plastics are recycled. Well, they don't really tell, that is a misleading question. It is 7% of your plastics, but it's not what they're trying to, I mean, make you believe it's 7% of the packaging, and it's not 7% of the packaging. So just you know, question some of that, but absolutely, you know, from a recycling standpoint, you know, we agree with those. We don't want to see, you know, we're all in this together. We agree. You know, really, the only difference between somebody that say, I want to say, is anti-plastic and our position is that we believe that even though the plastics are not going to go away, so we're trying to figure out a way of what to do with them. So we're all we share more thought. We're in agreement with more things than we are differences in that regard. So we're trying to make, we're ones that are trying to make sure that when you use it, it really is safe.
Thank you. With the increase in effort on advocacy and in context to increases in feedstock for recycling, will ABR leaning more towards EPR legislation or bottle bills or a combination of both? I think you have been supportive of EPR, if I understand it.
You're absolutely right. So about 2 years ago, we went to our membership and said, what do you need? And the big push was, we need more material. You know, at a couple years before that, it was, we needed more markets, you know. And so, you know, there's been a lot of, you know, there's organizations that are out there trying to improve collection, you know, giving you know, donating bins, donating whatever, and really the recycling rate hasn't changed. So APR's policies kind of has morphed a little bit into, we support any program that is done well. So a smart program that increases collection. And that could be a bottle bill. You know, not all bottle bills are good, and not all EPR is good, and you know, but when it's done well, and we just hired a new chief policy officer, if anybody knows her, Kate Bailey, who created or was kind of the sponsor of the EPR in Colorado. So we've got somebody that, you know, really knows her stuff now.
That's great. So our colleague Ed Nurk, Megan Fontes, has posted a comment. It is said that now every human on the planet has microplastics in their bloodstream. I do think that more will come out about microplastics and health, but you know, she points to the example of that aluminum is bad in deodorant and antiperspirant, for example, and you know, some of the information about that. She's also comments about, I wonder about biodegradable packaging too. There's no point unless consumers have a place to put them. What are appropriate collection points for those so that they can actually biodegrade? Not even all composts take those kinds of materials.
Right, and that's absolutely true. I agree with all of those, every one of those statements. That yeah, so, you know, there's a lot of, you know, I mean, when you really look at LCAs too, you know, life cycle analysis and then greenhouse gas, you know, it's really what you want to value, you know. If you look at LCAs, many times the plastics are, you know, fare pretty well on those, whereas if you look at you know, some of the items, some of the other packaging formats that don't get the press that that plastics do, don't fare so well. So I encourage everybody just to kind of look at the whole picture. And even on, you know, it's kind of this big rush to go make everything compostable or biodegradable, but hey, these are not things that degrade, that you can put in your composting, your compost pile in the back of your house. you know, it's going to be there. It's going to be there in 5 years or whatever. So there is not a whole lot of places to put that. Now, if you live in California, maybe there are a couple places that do that and have that. But agree with all of that.
Thanks, Curt. So somebody asked a very provocative question. Will there ever come a day of no plastics? It's hard to imagine our lives without plastics, honestly. I mean, you know, if you think about how often you touch plastics every day.
Yeah, there's been some challenges on that to say, hey, try to live your life without plastic. I mean, we're pretty much all would be sitting here naked. You know, you wouldn't have your glasses on. You know, we wouldn't have a computer in front of us. You wouldn't be driving a car. You know, yeah, so probably not, because there's a lot of things that plastics benefit. You know, you couldn't fly in an airplane because plastics make it light enough that you can actually fly. If you know, we burn a whole heck of a lot more fuel if the airplane was made out of whatever, out of metal and wood. You know, so there are definitely benefits for plastic, you know, lightness and strength and food product safety, and you know, with that other things can't give you, or we don't have another solution for, I should say. So and that's really where we are from the recycler standpoint, is we just kind of say, we don't believe it's going to happen, that the world is going to be completely without plastic. So what are we going to do to try to do the best thing we can, which is recycle it and reuse it and just be less wasteful? That's really what it's about.
Definitely less wasteful and more recyclable is key. So I think we're out of questions. And with the last very few minutes that we have left, I thought I would show folks some NUMOA's new website. But I want to encourage folks, if you do have questions, please continue to post them and I'll monitor that. Curt, can you see on the screen that I'm pulled up the NUMOA website to show people?
I can, and I think it'll be bigger if I close my, I'll turn my,
I'll turn my webcam off.
Yeah.
Yeah, let me turn it off.
And then, yeah, can have to, I can see it there, Terry.
So Curt, this was very helpful today. Really appreciate you sharing all this information. Just for folks, we just launched this website about a week ago. There's still some, you know, we're still working out some of the functions on the website, but pretty much we've moved all of the content from our old website to this new website, and it's a different platform. You can see we have different areas of work that we focus on, and in materials management, we've got a number of work groups. For example, you want to see all of our work groups. We did work on recycled content legislation. We did get a lot of comments on that from APR, which we really appreciated. But this group released recycled content legislation for plastic packaging and products last year, and it's a model legislation that we developed in collaboration with NERC. NERC led a lot of the effort. It was an effort of our memberships to put out some model legislation that we thought was based on both the laws in Washington State and New Jersey in particular, and also informed by the experience in California. So there's, you know, information about all of our work groups, a number of our projects. We've got a number of materials management projects underway. You can read about all of them on the website. In addition, you can view publications and search, say, if you want to look at all of our materials management materials, those are available. This is the model legislation that we published. And if you want to search our various events, and eventually this webinar will be available in this area of our new website. We've been doing some conversations and having some presentations on chemical recycling, and those are also available through this part of our website. Anything you want to know about NMOA and our history and our background is also available. Appreciate anybody's comments or suggestions on the website and how it appears. You can also scroll to get access to, a list, see what our events have been, what our publications are, some of the stats on our impact. Anyway, it's a new format. It's a whole new website for us. We're eager to hear what people think of it. Let's see. I don't see any further questions, Curt. So if that's true, then we can begin to wrap up a few minutes early.
Okay.
So again, I want to thank you. I want to let all the participants know we will be sometime soon posting the slides and the recording of today's webinar. It'll be available on just where I showed you on our website. And again, thank you so much. This has been a pleasure working with you, Curt, and take care, everyone. Have a good day.
Thank you, Terry. All right, bye.
Bye-bye.